Hello everyone, this is another continuation of artificial neural network. In the last module, we looked at the back propagation. There we had only one hidden layer. In the hidden layer, the first operation is to aggregate the product of the input data and weights, and then we pass through the activation function, and therefore we will have output. This output may not be the same as the supervised learning variable. Then we call it error, and the portion of error can be propagated back to the original the weights and compensate it. In this module, we will look at here the multiple hidden layers, so that we have input layer, and then the first hidden layer and second hidden layer, and fourth. And then finally we may have the output from the hidden layer. And each box here, if you see very carefully, this is the aggregation and activation function in a sequence. We represent it in one node, but actually there's two operations. So we have multiple layers there. So how can we implement that in Python? In this example, we look at the class called artificial neural network, and of course we have two sigmoid, the external functions defined. In this class, we have the initialization, and then feed forward and back propagates. If you see here feed forward, then you can see the first level, first layer. For the first layer, we have products between input and weight. So input and weight, and then products, and then we pass through the sigmoid, and then that sigmoid and then the second weight is multiplied, and then passes through another sigmoid. And at the end here, at this point, we realize that there is an error. There is a difference between the output that we obtained from this the computation and the given supervised learning values. Then we need to take that difference into consideration to accommodate the original weights. That portion needs to go back to another layer of the weights. This back propagation goes until when we have the input data. Okay, so it goes here, for example, back propagates. Then we first find an error, and then we have the first layer, which is toward the end of that the neural computations. Pass through the derivatives, and then we have the adjustment, and then we after we have this, then we need to product with this one with the weights. Okay, this is the difference, and with the weights, and then that is the error, and that will be again go through the derivatives, and then the output will be again the products. So this this is one time of back propagation. So we can do that multiple times. How it can be, you can feed forward and backward. Therefore, the weights at each layer will be adjusted, which means the weights can be trained sufficiently. Therefore, we can use this the neural network to deploy for the real actual uh, cases. Okay, so to make it simple, and run it. So we can see here train the initial. Initially, we have weights, for example, W1 weights, which is this W1s, so n by n, and W2 n by 1. So we have this weights, two-dimensional, and W2 is in this weight. These weights can be trained. I want to see negative 0, 1, 0, 0, 1. It goes all the way here, negative 0, 1, 0, 1. So this is a final version of a trained W2 in that iteration. But if we do this, for example, this is 100 thousands times 200, then at most it goes up to 20 million iterations. Okay, we can see it. It takes